Right now, you are sitting on a rock, spinning through space at 67,000 miles an hour. Not metaphorically, not approximately. Right now, the Earth is moving through its orbit around the Sun at that speed, faster than any human technology has ever traveled, faster than any bullet ever fired. And at the same time, your entire solar system is orbiting the center of the Milky Way at 500,000 miles an hour. And the galaxy itself is moving through the largest structure of the universe at speeds that make those numbers seem small. You are not still, you have never been still. And yet here you are, lying quietly in the dark, and the universe holds you as gently as if you were not moving at all. Tonight we're going to travel outward. We'll start here with the ground beneath you, and we'll move slowly outward, past the moon, past the sun, past the nearest stars, past galaxies, all the way to the edge of what we can see. 100 facts about the universe, offered slowly, designed for sleep. You don't need to remember any of this. You don't need to follow every number or every name. Just let it drift through you, the way starlight drifts through space. Let the scale of things make the noise in your head feel a little smaller. Before we drift out into the stars, a quiet word. MindFall is a new channel built for one simple reason. Most of us don't sleep well. Our minds race when the world finally goes quiet. So I'm building a place where real science meets the dark hours, where the vastness of the universe can make the noise in your head feel a little smaller. If this journey helps you drift away tonight, a subscribe or a like would mean everything to me. It helps the algorithm carry this channel to other restless minds out there in the dark, and it keeps this small mission alive. Now get comfortable, dim the light, let's leave the Earth behind for a while. Fact number 1, the Earth is spinning right now beneath you. The Earth rotates once every 24 hours, which means the surface at the equator is moving at just over 1,000 miles an hour relative to the planet's axis. You don't feel this because everything around you, the air, the ground, the atmosphere, is moving with you. The spin is constant, and it has been constant for billions of years. It is the reason you have a day and a night. It is the reason the stars appear to move across the sky. It is the quiet engine beneath every morning and every evening you have ever experienced. Right now, somewhere on the other side of this turning rock, the sun is rising. Fact number 2, the Earth is not perfectly round. It bulges slightly at the equator and is flattened at the poles, a shape that physicists call an oblate spheroid. This is because the planet's rotation pushes matter outward at the equator, the same way a spinning ball of dough spreads wider in the middle. The difference between the equatorial and polar diameter is about 27 miles, tiny compared to the Earth's full width of nearly 8,000 miles, but measurable, real, a consequence of spin. The mountain that rises highest from the center of the Earth is not Everest. It is Chimborazo in Ecuador, which sits near the equator and benefits from the extra bulge. Fact number 3, the moon is moving away from us. Every year, the moon drifts about 1.5 inches farther from the Earth. This is a consequence of the tidal forces between them. The oceans on Earth, pulled by the moon's gravity, create a slight tidal bulge that runs just ahead of the moon's position. This bulge exerts a small gravitational pull on the moon, slowly pushing it into a higher orbit. When the moon first formed, roughly 4.5 billion years ago, it was perhaps 15 times closer than it is today, close enough that the tides it created were enormous, hundreds of feet tall, washing continents that had barely finished forming. It has been slowly leaving ever since, gently, at the pace of a growing fingernail. Fact number 4, the moon stabilizes Earth's tilt. Without the moon, Earth's axial tilt would wander erratically over millions of years, swinging between nearly upright and dramatically tilted. The moon's gravity acts as a stabilizer, holding the tilt to a relatively narrow range of 22 to 25 degrees. This consistency is one reason Earth has had stable enough seasons over billions of years for complex life to develop. Mars has no large moon. Its axial tilt has varied wildly over geologic time, from nearly upright to tilted nearly on its side. This instability is one of the things that makes Mars so difficult to understand from a climate perspective. The moon, quiet and silver above you, is one of the reasons the world is habitable enough for you to be lying in it. Fact number 5. A day on Earth is getting longer. Not quickly, by about 2 milliseconds every 100 years, but measurably. The same tidal forces that push the moon outward also gradually slow Earth's rotation. The friction of the ocean tides, generated by the moon's pull, acts as a brake on the spinning planet. Very slowly, very gently, the days grow longer. 4 billion years ago, a day on Earth lasted only about 6 hours. The young sun would have risen and set 4 times in the span of what we now call a day. The sky was likely orange with a thick early atmosphere, and the oceans were warm, and the 6-hour days passed one after another in a world that had not yet learned what life was. Fact number 6. The atmosphere is an extraordinarily thin shell. If the Earth was shrunk to the size of an apple, the entire atmosphere, all the air you have ever breathed, everything that has ever flown or been blown by the wind, would be no thicker than the skin of that apple. The breathable part, where nearly all weather occurs and where nearly all life lives, extends only about 7 to 10 miles above the surface. Commercial aircraft fly near the top of this layer. Above that, the air thins so rapidly that a person without a pressurized suit would lose consciousness in seconds. The sky looks blue from inside this thin shell. From outside it, the sky is simply black. The blue is a product of the shell, not of space. Fact number 7. The Earth's magnetic field is why life survived. The liquid iron in Earth's outer core churns constantly, driven by heat from the planet's interior, and this churning generates a magnetic field that surrounds the planet like an invisible shield. Without it, the solar wind, the constant stream of charged particles flowing out from the sun, would strip away the atmosphere over millions of years, the way it stripped away Mars's atmosphere when that planet's magnetic field weakened and died. The magnetic field deflects the most harmful radiation. It channels particles toward the poles, where they collide with atmospheric gases and produce the aurora borealis and aurora australis, the northern and southern lights. Those curtains of color are the visible mark of a shield that has been protecting this planet for billions of years. Fact number 8. The sky is dark at night because the universe has not existed forever. This seems obvious, but it was a genuine puzzle for centuries. If the universe were infinite and eternal and filled with stars in all directions, then every line of sight from any point in space would eventually terminate on a star. The night sky should be as bright as the surface of the sun in every direction. It isn't, and the reason is time. The universe is about 14 billion years old, which means we can only see light that has had time to reach us. The observable universe is finite, not because space ends somewhere, but because time began somewhere. Light from stars farther away has not yet arrived. The darkness of the night sky is evidence that the universe had a beginning. Fact number 9. The moon's surface has footprints that will last for millions of years. The moon has no atmosphere and no weather. There is no wind to blow dust, no rain to smooth surfaces, no geological activity churning the top layer of soil. The footprints left by the 12 people who walked on the moon between 1969 and 1972 are still there, preserved with perfect clarity in the lunar dust. They will remain recognizable, barring a meteor impact, for millions of years. In that time, the continents of Earth will have moved significantly. The languages spoken on Earth will have changed beyond recognition. Species that exist today will have evolved into different forms or gone extinct. And on the Moon, a set of boot prints will sit undisturbed, as crisp as the day they were made. Fact number 10. The Earth is 4.5 billion years old. Written out, that number looks like this: 4,500 million years. The universe is about 3 times older. The Sun is roughly the same age as the Earth. They formed together from the same cloud of gas and dust. The oldest known rocks on Earth are about 4 billion years old. The oldest known minerals, individual zircon crystals, are about 4.5 billion years old, nearly as old as the planet itself. They were formed in the first 100 million years of Earth's existence, when the planet was still cooling from its formation, still being bombarded by the leftover debris of the early solar system. Those crystals still exist. You could hold one in your hand. Fact number 11. The Milky Way can be seen with the naked eye if the sky is dark enough. In places far from artificial light, on a clear night, you can see a faint band of light arching across the sky. That is the combined light of hundreds of billions of stars, so far away that they blur together into a glow. You are inside it. You are seeing it edge on from a position about halfway between the center and the outer edge. The bright region toward the constellation Sagittarius is the galactic center, the direction of the supermassive black hole that anchors our galaxy. Most people living today have never seen the Milky Way with their own eyes. Light pollution from cities has made it invisible to roughly a third of humanity. Fact number 12. Every atom in your body was forged in a star. The hydrogen atoms in your body, in the water you're made of, are about 14 billion years old. They were produced in the first few minutes after the Big Bang, in the primordial nucleosynthesis that filled the early universe with simple elements. The heavier atoms, the carbon, the oxygen, the nitrogen, the calcium, the iron in your blood, were made in the cores of massive stars, billions of years before the sun was born. Those stars lived out their lives, burned through their fuel, and exploded, scattering the elements they had created across the galaxy. From that scattered material, eventually, the solar system formed, and from that material, eventually, you. You are not merely made of star stuff. You are what stars do when they have enough time and enough quiet. Fact number 13. The Earth's surface is in constant slow motion. The continents drift on enormous plates of rock, moving at roughly the speed of a fingernail growing, a few inches per year. Over millions of years, this adds up. 250 million years ago, all the land on Earth was gathered into a single supercontinent called Pangaea. Over the following hundreds of millions of years, it broke apart, the pieces drifting to their current positions. The Atlantic Ocean did not exist when the dinosaurs walked the Earth. It is still widening today by about an inch a year as North America and Europe slowly drift apart. The Himalayas are still rising, pushed up by the collision of the Indian and Eurasian plates, a collision that has been ongoing for 50 million years. The ground you're lying on is not where it was. It is not where it will be. Fact number 14. The Earth has a second companion. Beyond the Moon, Earth has a small asteroid called 3753 Cruithne that follows a complicated orbit around the Sun, an orbit that makes it appear, over time, to trace a horseshoe path near Earth. It is not a second moon in any traditional sense. It does not orbit Earth the way the Moon does, but it is gravitationally linked to our planet in a loose, meandering way, a companion that has been following us through the solar system for millions of years without most people knowing it exists. There are other small objects in similar relationships. Earth is not as alone in its neighborhood as it appears. Fact number 15. From space, Earth is the pale blue dot. In 1990, the Voyager 1 spacecraft was about 4 billion miles from Earth when it turned its camera back toward the inner solar system and photographed the sun and planets. Earth appeared as a mote of dust suspended in a sunbeam, a pale blue point of light, barely distinguishable from the surrounding dark. Carl Sagan, who advocated for this photograph to be taken, described it as a reminder that everyone who has ever lived, every king and every peasant, every moment of human history, every act of love and cruelty and ambition took place on that pale blue dot. The photograph is not humbling in a diminishing way. It is humbling in the way that all genuine perspective is. It shows you where you are so that you can know what it means to be here. We've left the ground now. We're moving outward, past the moon and into the wider solar system, past the planets, toward the edge of everything the sun touches. Fact number 16. The light you see from the sun left 8 minutes ago. Traveling at the speed of light, about 186,000 miles per second, sunlight takes roughly 8 minutes and 20 seconds to cross the 93 million miles between the sun and Earth. When you look at the sun, you are seeing it as it was 8 minutes in the past. When you look at the moon, you are seeing it as it was about a second and a quarter ago. When you look at distant stars, you are looking further and further into the past. The night sky is a time machine. Everything visible in it is historical light, information that left its source long before it reached your eyes. Fact number 17. If the sun were the size of a basketball, Earth would be a peppercorn. And that peppercorn would be about 25 meters away from the basketball. This is a common scale model used to make the solar system's emptiness tangible. In this model, Jupiter, the largest planet, would be a marble, roughly 100 meters from the basketball sun. Neptune would be another marble, but nearly half a kilometer away. Between those points, very little, mostly empty space, with the occasional grain of sand or smaller particle drifting through it. The solar system is almost entirely empty. What we call it, a system, a neighborhood, implies a kind of closeness that the actual distances don't support. Fact number 18. Jupiter is large enough to contain all the other planets. If all 7 other planets in the solar system were combined, Jupiter would still be larger than the resulting mass. Jupiter is primarily hydrogen and helium, a gas giant that never accumulated quite enough mass to ignite nuclear fusion and become a star. If it were about 70 times more massive, the pressure at its core would be sufficient to begin fusing hydrogen, and our solar system would have 2 suns. Instead, it is the largest planet, a world of swirling bands and enormous storms with no solid surface, where the atmosphere gradually transitions to liquid and then perhaps to a metallic hydrogen core at extreme pressure. Fact number 19. The Great Red Spot on Jupiter is a storm larger than Earth. It has been observed continuously since at least the 17th century, a storm that has been raging without stopping for at least 350 years. It is approximately 1.5 times the width of Earth. The winds within it reach speeds of several hundred miles per hour. The exact mechanism that keeps it persistent and organized, while most storms on Earth dissipate within days or weeks, is still being studied. In recent decades, the Great Red Spot has been shrinking, something that has puzzled scientists who expected it to be stable indefinitely. It may eventually dissipate, or it may stabilize at a smaller size. 3.5 centuries of observation, and the storm still holds its mysteries. Fact number 20. Saturn's rings are made of ice and rock, and they are very thin. The rings of Saturn extend roughly 70,000 miles from the planet's surface, wide enough to fill most of the distance between Earth and the Moon. But they are astonishingly thin. In most places, the rings are only about 30 feet thick. Imagine a sheet of paper scaled up until it was 400,000 times wider than it was thick. That is roughly the proportional structure of Saturn's rings. They are composed of particles ranging from small grains to objects the size of houses, all made primarily of water ice with some rock. They glitter in sunlight. From the right angle, they can be seen to cast a shadow across Saturn's cloud tops, a thin, dark line across a planet that is 9 times wider than Earth. Fact number 21. A day on Venus is longer than a year on Venus. Venus rotates on its axis so slowly that it takes longer to complete one rotation than it takes to complete one full orbit around the Sun. A Venusian day, one complete rotation, lasts about 243 Earth days. A Venusian year, one orbit around the Sun, lasts about 225 Earth days, so the day is longer than the year. Additionally, Venus rotates in the opposite direction from most planets. On Venus, the Sun rises in the west and sets in the east. No one knows exactly why Venus rotates this way. The best hypotheses involve an ancient collision or gravitational interactions, events that happened so long ago that the evidence has been largely erased. Fact number 22. Mars has the largest volcano in the solar system. Olympus Mons rises about 16 miles above the Martian surface, roughly 3 times the height of Mount Everest above sea level. Its base is about the size of the state of Arizona. It is a shield volcano, formed by the slow accumulation of lava flows over billions of years. On Earth, volcanic hotspots create chains of islands as the tectonic plates move over them. Hawaii is a good example. But Mars lacks plate tectonics, so the plate never moves, and the volcano just keeps growing over the same hotspot. Standing at the base of Olympus Mons, you would not be able to see the summit. It would be beyond the Martian horizon. Standing at the summit, you would not be able to see the base for the same reason. Fact number 23. Pluto has mountains of ice. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a world of surprising complexity. Mountain ranges made of water ice, reaching heights comparable to the Rockies, rising from plains of nitrogen ice. Pluto is so cold, about -375 degrees Fahrenheit, that nitrogen, which we breathe as a gas, exists there as ice. Water ice, at those temperatures, behaves more like rock, rigid, structural, capable of forming mountains. The heart-shaped plain of nitrogen ice, now called Tombaugh Regio, named after the astronomer who discovered Pluto in 1930, is one of the most striking features photographed in the outer solar system. It convects slowly, like an enormous icy lava lamp, turning over in cycles that take millions of years. Fact number 24. The asteroid belt is mostly empty. Despite what films often suggest, the asteroid belt between Mars and Jupiter is not a dense field of tumbling rocks that a spacecraft must navigate carefully. It is enormous and almost entirely empty. The total mass of all the asteroids in the belt combined is less than 4% of the Moon's mass. The average distance between asteroids is about 600,000 miles. The Voyager, Pioneer, New Horizons, and other spacecraft passed through the asteroid belt without incident, with no particular need to adjust course. What makes the belt interesting is not its density, but its origin. It is the material that never coalesced into a planet, prevented by Jupiter's enormous gravity from gathering into a single body. Fact number 25. Neptune has winds faster than any other planet. Despite being the farthest planet from the Sun, Neptune has the most violent weather in the solar system. Its winds reach speeds of over 1,000 miles per hour, fast enough that sound, if it could travel there, would be supersonic. Why a planet so far from the Sun's energy input has such extreme weather is not fully understood. Neptune generates more heat from its interior than it receives from the Sun, which may contribute. The dynamics of its thick atmosphere and the way internal heat drives circulation remain an active area of research. What we know is that on Neptune, the calm distances of the outer solar system are deceptive. Out there, in the dark, something enormous is raging. Fact number 26. The edge of the solar system is not a line, but a gradual fading. Beyond the planets, the Sun's influence extends in two meaningful ways. The heliosphere is the bubble created by the solar wind, the constant flow of particles from the Sun. It extends roughly 100 astronomical units from the Sun in most directions. Voyager 1, launched in 1977, crossed this boundary in 2012, becoming the first human-made object to enter interstellar space. Beyond the heliosphere, the Sun's gravitational influence continues much farther, perhaps 2 light-years in the form of the Oort cloud, a vast and distant reservoir of comets. An object from the Oort cloud, dislodged by a passing star or some other disturbance, might fall toward the Sun and arrive in the inner solar system as a comet, spending most of its existence in the dark cold of the outermost solar system, visiting the inner planets only rarely. Fact number 27. Saturn is less dense than water. If you could find a bathtub large enough and an ocean of water large enough to fill it, Saturn would float. Saturn's average density is about 7/10 of the density of water. This is because the planet is composed almost entirely of hydrogen and helium, the lightest elements in the universe, in a compressed, partially liquid state. This fact tends to strike people as strange the first time they hear it, as if it implies something fragile or lightweight about Saturn. But Saturn is 700 times more massive than Earth. It could contain 700 Earths inside its volume. The floating is just math, a consequence of what it's made of, not of how large or massive it is. Fact number 28. Venus has a surface hot enough to melt lead. The average surface temperature on Venus is about 860 degrees Fahrenheit, hotter than Mercury, the closest planet to the Sun. The reason is Venus's atmosphere, which is thick with carbon dioxide and creates an extreme greenhouse effect. The atmosphere traps heat so efficiently that the temperature difference between the sunlit side and the night side of Venus is almost nothing. The whole planet is equally, continuously, extraordinarily hot. The atmospheric pressure at the surface is about 90 times Earth's, equivalent to being 900 meters underwater. The Soviet Venera probes that landed on Venus in the 1970s and 1980s were crushed and destroyed within about an hour. They managed to send back photographs before they failed, the only images we have of Venus's surface taken from ground level. Fact number 29. The solar system is about halfway through the Sun's life. The Sun has been burning for about 4.5 billion years. It has roughly 5 billion years of hydrogen fuel left in its core. When that fuel is exhausted, the Sun will expand, swelling into a red giant large enough to engulf Mercury and Venus and possibly Earth. It will then shed its outer layers as a planetary nebula, leaving behind a dense remnant called a white dwarf. That white dwarf will cool over billions of years until it becomes a dark, cold object, a black dwarf, though the universe is not yet old enough for any white dwarf to have cooled completely. The Sun is a middle-aged star in the long middle of its life, shining with the steady reliability that middle age implies. Fact number 30. The solar wind touches every planet in the solar system simultaneously. The stream of charged particles flowing out from the Sun moves at speeds of roughly 1,000,000 miles per hour. It fills the entire heliosphere, touching every planet, every moon, every asteroid. When it reaches a planet with a magnetic field, like Earth or Jupiter, it is deflected and causes auroras. When it reaches a planet without one, like Mars or Venus, it interacts directly with the upper atmosphere, slowly stripping it away over geological time. The solar wind is a kind of breath, constant, invisible, filling all the space between the planets with something. The solar system is not empty. It is filled with this continuous exhalation of the sun. We've crossed the solar system now. Ahead lies the realm of the stars, vast distances measured not in miles, but in the time it takes light to cross them. Fact number 31. The nearest star is 4 light-years away. Proxima Centauri is the closest star to our Sun, about 4¼ light-years away, which means the light we see from it tonight left its surface about 4¼ years ago. If we could travel at the speed of our fastest spacecraft, it would take about 70,000 years to reach it. If we could somehow travel at the speed of light, the journey would take 4 years, a long voyage, but an imaginable one. Proxima Centauri is a red dwarf, smaller and cooler and dimmer than our Sun. It has at least one planet in its habitable zone, a world called Proxima b, orbiting where liquid water could theoretically exist. Whether it does, we do not know. The nearest star, 4¼ light-years. The universe has arranged things with a great deal of room between them. Fact number 32. Stars are born inside clouds of gas and dust. Scattered through the galaxy are vast nebulae, clouds of hydrogen gas and dust that can span hundreds of light-years. These are the nurseries of stars. When a region of such a cloud becomes dense enough, perhaps triggered by the shockwave of a nearby supernova or the gravitational disturbance of passing objects, it begins to collapse under its own gravity. As it collapses, it heats. If enough material gathers, the center grows hot enough and dense enough to trigger nuclear fusion, and a star ignites. The Orion Nebula, visible on clear nights as a faint smudge in the constellation Orion, is one such star-forming region. Inside it, new stars are being born right now. The light from those forming stars has been traveling for about 1,000 years before reaching your eyes tonight. Fact number 33. The Sun fuses 600 million tons of hydrogen every second. In the Sun's core, where temperatures reach about 27 million degrees Fahrenheit, hydrogen atoms are forced together to form helium atoms. The combined mass of the resulting helium is slightly less than the mass of the hydrogen that went in. That small difference in mass is converted directly to energy, the energy that lights and heats our solar system. The equation is Einstein's most famous, E equals mc squared. A tiny amount of mass, multiplied by the speed of light squared, produces an enormous amount of energy. The Sun loses about 4 million tons of mass every second. It has been doing this for 4.5 billion years. It has fuel for about 5 billion more. Fact number 34. A teaspoon of neutron star material would weigh 1 billion tons. When a massive star, much larger than our Sun, reaches the end of its life and its core collapses, the result can be a neutron star. A neutron star is the collapsed remnant of a stellar core, compressed to an object typically about 12 miles across, the size of a city, but containing more mass than the Sun. The compression is so extreme that the atoms themselves are crushed, protons and electrons merging into neutrons, until the object is essentially one giant atomic nucleus. The density of a neutron star is roughly the density of an atomic nucleus scaled to an enormous size. If you could place a teaspoon of its material on Earth, the gravitational attraction to the planet would be enormous. The teaspoon would sink through the ground and fall toward the center of the Earth before the planet itself was disrupted. Fact number 35. Some stars are larger than the entire orbit of Jupiter. Among the largest known stars are red hypergiants, stars so massive that if they replaced the Sun at the center of our solar system, their surface would extend past the orbit of Jupiter. These are some of the largest objects in the universe. VY Canis Majoris, one of the largest known stars, has a radius roughly 1,000 times that of the Sun. If you could drive around its equator at highway speed, the journey would take about 1,000 years. They are also profoundly unstable. Stars of this size live relatively short lives, millions of years rather than billions, and they die dramatically. Fact number 36. When a massive star dies, it creates all the heaviest elements. Stars up to about 8 times the mass of our Sun fuse hydrogen to helium, and then helium to carbon, and then some further elements, ending when they can no longer sustain fusion. They expand into red giants and shed their outer layers. More massive stars can fuse elements all the way up through the periodic table: carbon, oxygen, neon, magnesium, silicon, and eventually iron. Iron is the end of the line for fusion in a stellar core. Fusing iron requires energy rather than releasing it. When an iron core forms, the star collapses catastrophically. The collapse and the rebound create a supernova, an explosion visible across billions of light years. In those extreme conditions, elements heavier than iron are forged: gold, platinum, uranium. Then the explosion scatters them. The gold in any ring, anywhere on Earth, was created in the death of a star. Fact number 37. White dwarfs will outlast almost everything. When a star like our Sun exhausts its fuel and sheds its outer layers, what remains is a white dwarf, the dense, hot core about the size of Earth but vastly more massive. A white dwarf is not undergoing fusion. It shines only because it is still hot from its star's long life, and it cools over billions and billions of years. Eventually, theory suggests, it will cool into a dark, cold object called a black dwarf. But the universe is not yet old enough for any white dwarf to have cooled that far. Every white dwarf that exists is still glowing. They will outlast their home galaxies, outlast the era of star formation, shine on in the cooling darkness of the far future for trillions of years. Fact number 38. The space between stars is not empty. Interstellar space is filled with the interstellar medium, a diffuse mix of gas, dust, cosmic rays, magnetic fields, and radiation. The gas is mostly hydrogen and helium, incredibly thin, typically less than 1 atom per cubic centimeter in most places, compared to about 10 billion trillion atoms per cubic centimeter in the air around you. But integrated over the enormous volumes between stars, it amounts to a significant mass. The dust, tiny solid particles of silicates and carbon compounds, absorbs and scatters starlight, making distant objects appear dimmer and redder than they actually are. This interstellar reddening was one of the puzzles astronomers had to understand before they could accurately measure the distances to other galaxies. The space between stars is not nothing. It is simply very, very thin. Fact number 39. The most common type of star in the galaxy is invisible to the naked eye. Red dwarfs, small, cool, dim stars, make up about 3/4 of all the stars in the Milky Way. Not one of them is visible to the naked eye from Earth because they are so faint. Proxima Centauri, our nearest stellar neighbor, is a red dwarf. Despite being the closest star to our Sun, it cannot be seen without a telescope. Red dwarfs burn their fuel so slowly and conservatively that they can live for trillions of years, far longer than the current age of the universe. The red dwarfs forming today will still be burning when the universe is 100 times older than it is now. In the very far future, when all stars like our Sun have long since burned out, the galaxy will belong to the red dwarfs alone. Fact number 40. The speed of light is the universe's speed limit. Nothing with mass can reach the speed of light. As an object accelerates, it gains energy, and that energy also increases its effective mass. As it approaches the speed of light, the energy required to accelerate it further approaches infinity. You cannot get there. Light itself travels at this speed because photons, particles of light, have no mass. They are not pushing against the barrier, they simply are the barrier. This limit shapes everything about how we experience the universe. It is the reason the observable universe has a boundary. It is the reason we see distant galaxies as they were in the past. It is the reason that as the universe expands, some distant regions recede faster than light can cross the growing distance, meaning we will never receive any signal from them, no matter how long we wait. Fact number 41. Stars twinkle because of Earth's atmosphere. In space, they don't. The twinkling of stars, their apparent flickering as you watch them, is caused by the Earth's atmosphere. As starlight passes through the atmosphere, it is refracted by small pockets of air at different temperatures and densities, bending the light slightly different ways from moment to moment. Planets appear to twinkle less because they are close enough to present a tiny disk of light rather than a pure point. The turbulence averages out across the disk. In space above the atmosphere, stars shine with a steady, unwavering light. Astronauts on the International Space Station see a sky full of points of light that don't twinkle at all, bright and still, millions of them visible simultaneously, undimmed by the blanket of air that stands between us and them. Fact number 42. Some stars pulsate in size. A class of stars called Cepheid variables expand and contract in regular cycles, swelling in size, then shrinking, then swelling again over periods of days to weeks. As they expand and contract, their brightness changes in a predictable, measurable way. This property made them enormously valuable to astronomers. There is a precise mathematical relationship between a Cepheid's pulsation period and its true luminosity. By measuring the period and comparing the true luminosity to the apparent brightness as seen from Earth, astronomers can calculate the distance to the star. Cepheid variables were the tool that allowed Edwin Hubble in the 1920s to determine that the Andromeda galaxy was far outside our own Milky Way, a measurement that revealed the true scale of the universe for the first time. Fact number 43. The night sky contains the light of dead stars. Many of the stars visible to the naked eye tonight are hundreds or thousands of light years away. The light you see from them left its source centuries or millennia ago. Some of those stars no longer exist. They may have exploded or collapsed in the time that their light has been traveling toward you. You are seeing a ghost, the light of something that is gone. There is no way to know from Earth which stars in the sky are still burning and which have died in the time since their light was emitted. All of it arrives together, the light of the living and the dead, indistinguishable, crossing the same dark distances to reach the same eyes at the same moment. Fact number 44. Binary star systems are common. More than half of all sun-like stars are found in binary or multiple star systems, orbiting another star, sometimes a third or fourth as well, in gravitational partnership. Our single sun is actually somewhat unusual. In binary systems, the two stars orbit a common center of mass, sometimes close enough that one can pull material from the other, sometimes so far apart that planets could orbit one star without being significantly disturbed by the other. Some binary systems are visible to the naked eye as two closely spaced points of light. Others are detectable only because they periodically eclipse each other, dimming the combined light in a regular pattern. The universe, when it makes stars, often makes them in pairs. Fact number 45. The center of our galaxy is hidden behind dust. The galactic center, where the supermassive black hole called Sagittarius A star resides, lies about 26,000 light-years from Earth in the direction of the constellation Sagittarius. We cannot see it in visible light because of the dense clouds of gas and dust that fill the plane of the galaxy, blocking the view. To observe the galactic center, astronomers must use infrared or radio telescopes, which can penetrate the dust where visible light cannot. When radio telescopes and infrared observatories do peer toward Sagittarius, they reveal extraordinary activity, stars orbiting an invisible point at speeds only possible if something with the mass of 4 million suns were concentrated there. The black hole at the center of our galaxy cannot be seen directly, but everything around it testifies to its presence. We've left the stars behind now. We are moving into the territory of black holes and the most extreme conditions the universe allows. Fact number 46. Nothing that falls into a black hole can escape. A black hole is a region of space where gravity is so intense that the escape velocity, the speed needed to break free, exceeds the speed of light. Since nothing with mass can travel at or beyond the speed of light, nothing can escape. Not light, not information, not time as we experience it. The boundary of this region is called the event horizon, the point of no return. Nothing that crosses the event horizon has ever sent back any information about what lies beyond. All of our knowledge of what happens inside a black hole comes from theory, not observation. The interior of a black hole is the most inaccessible place in the universe. Fact number 47. Time slows near a black hole. This is not a metaphor or a simplification. It is a consequence of general relativity confirmed by observation. Near a massive object, space-time curves. The stronger the gravity, the more pronounced the curvature, and one effect of this curvature is the slowing of time. An observer hovering near a black hole, if such a thing were possible, would experience time passing more slowly than an observer far away. To the far observer, the hovering person would appear to age slowly, to move slowly, to speak slowly. The hovering person would feel nothing unusual. From their perspective, time would pass normally, but the two clocks would fall steadily out of synchronization. At the event horizon itself, an outside observer would see time appearing to stop entirely. The person falling in would not notice. They would cross the horizon and continue falling. But the universe they left behind would appear, to them, to suddenly rush forward into the far future. Fact number 48. Stellar black holes form in the death of massive stars. When a star more than about 20 times the mass of our Sun exhausts its nuclear fuel, the core collapses. The outer layers fall inward. The collapse is so rapid and so extreme that the resulting density exceeds the density of a neutron star. The core becomes a singularity, a point of infinite density or something approaching it, at which our current understanding of physics breaks down. Surrounding it, the event horizon forms. The outer layers of the star either fall in or are flung outward in a supernova explosion. The resulting black hole may be 10 or 20 or 30 times the mass of the Sun, compressed to a singularity surrounded by an event horizon perhaps a few tens of miles across. It pulls on the space around it, bending light, distorting time, accumulating whatever material drifts close enough. Fact number 49. Supermassive black holes exist at the centers of most galaxies. The black hole at the center of the Milky Way, Sagittarius A star, is about 4 million times the mass of our Sun. That sounds extraordinary, but compared to the largest known supermassive black holes, it is modest. The black hole at the center of the galaxy, M87, photographed for the first time in 2019, is about 6.5 billion times the mass of our Sun, over 1,000 times more massive than the one in our own galaxy. How black holes of this scale form is an active question in astrophysics. They cannot have grown simply by accumulating matter at normal rates over the age of the universe. The numbers don't work. They may have started large, from the direct collapse of enormous gas clouds in the early universe, or grown through mergers of smaller black holes, or both. Fact number 50. Quasars are among the brightest objects in the universe. In the early universe, when it was young and dense and galaxies were first forming, some supermassive black holes were surrounded by so much infalling material that they radiated with extraordinary luminosity. These active galactic nuclei, when seen from billions of light years away, appear as extraordinarily bright point-like objects. Astronomers originally called them quasi-stellar objects, quasars. The most luminous quasars outshine their entire host galaxies by factors of hundreds or thousands. They are visible from across the observable universe. When we observe the most distant quasars, we are seeing light that left the early universe when it was less than 1 billion years old, seeing the universe as it was nearly 13 billion years ago, when it was young and violent and blazing. Fact number 51. Pulsars are the universe's most accurate clocks. When a massive star collapses into a neutron star, the resulting object often rotates extremely rapidly. Conservation of angular momentum, the same principle that makes a figure skater spin faster as they pull in their arms, applied to the collapse of a star. Some neutron stars rotate hundreds of times per second, emitting beams of radio waves from their magnetic poles. If the beam sweeps past Earth with each rotation, we receive regular radio pulses, as regular as the ticking of the finest atomic clock, sometimes more so. These are pulsars. The most stable pulsars keep time so precisely that they have been used to test general relativity, to search for gravitational waves, and as potential navigational beacons for spacecraft. The universe has built, in the wreckage of dying stars, some of the most accurate timekeepers that exist. Fact number 52. Gravitational waves are ripples in spacetime itself. Einstein's general theory of relativity predicted that massive objects in motion would create waves in the fabric of spacetime, ripples spreading outward like waves on the surface of water, but the water is the geometry of space itself. For a century, these waves were theoretical. In 2015, they were directly detected for the first time when the LIGO detectors, instruments of extraordinary precision, able to measure a displacement smaller than 1,000th the width of a proton, registered the gravitational waves produced by two black holes merging about 1.5 billion light-years away. The event lasted about 1/5 of a second. The two black holes, each dozens of times the mass of our Sun, spiraled together and merged. In that final fraction of a second, they radiated more power than all the stars in the observable universe combined. We detected the whisper of it from 1.5 billion light-years away. Fact number 53. Black holes can evaporate. Stephen Hawking showed, through a combination of quantum mechanics and general relativity, that black holes are not entirely black. Near the event horizon, quantum effects produce pairs of particles, matter and antimatter, one of which can escape while the other falls in. From a distance, the black hole appears to radiate energy. This is called Hawking radiation. For any black hole of stellar mass, the Hawking radiation is unimaginably faint, far colder than the cosmic microwave background radiation that fills the universe. Such a black hole would gain energy from that background faster than it loses it through Hawking radiation. Only in the far future, when the universe has cooled enough, would stellar mass black holes begin to slowly evaporate. Over timescales almost impossible to write down, they would shrink and eventually disappear in a last burst of radiation. The universe's most permanent-seeming objects are, on the longest timescales, temporary. Fact number 54. The universe has web-like structure. On the largest scales, matter in the universe is not distributed randomly. It is organized into a vast cosmic web, a filamentary structure of galaxy clusters and superclusters connected by filaments of dark matter and gas, with enormous voids between them. The filaments contain most of the galaxies. The voids, some of which are hundreds of millions of light-years across, contain almost nothing. This structure emerged from tiny quantum fluctuations in the density of the very early universe. Those fluctuations were amplified over billions of years by gravity, dense regions attracting more matter, becoming denser, while underdense regions became emptier. The cosmic web is the universe's grandest sculpture, carved by gravity from the near uniformity of the early cosmos. Fact number 55. Neutron stars can merge and create gold. When two neutron stars in a binary system spiral inward and merge, the collision creates a kilonova, an explosion fainter than a supernova, but still extraordinarily bright. In the extreme conditions of the merger, densities and temperatures beyond anything else in the current universe, heavy elements are synthesized in a process called rapid neutron capture, or the R process. This creates gold, platinum, uranium, and other heavy elements that cannot be produced inside stars. In 2017, gravitational wave detectors and astronomical observatories together observed a neutron star merger, the gravitational waves and the light from the kilonova simultaneously. The observation confirmed that neutron star mergers are a primary source of gold in the universe. Some fraction of every gold atom on Earth was made in the collision of two neutron stars, billions of years before the Sun was born. We're moving further out now, past individual stars and black holes and into the great structures of the universe, the galaxies. Fact number 56. The Milky Way contains between 200 and 400 billion stars. The uncertainty in that estimate is itself significant. We cannot count them directly. We estimate based on the galaxy's mass, the distribution of stellar types we can observe, and measurements of the galaxy's structure. If you tried to count the stars of the Milky Way at 1 per second, without stopping, it would take about 6,000 to 12,000 years. The galaxy itself is about 100,000 light-years across. The Sun sits roughly 26,000 light-years from the center, in a minor arm called the Orion Arm. We orbit the galactic center once every 230 million years or so, a period sometimes called a galactic year. In the roughly 4.5 billion years since the Earth formed, we have completed about 20 trips around the galaxy. Fact number 57. The Andromeda Galaxy is heading toward us. Andromeda, the nearest large galaxy to the Milky Way, is about 2.5 million light-years away. The light you see from it on a dark night left its home 2.5 million years ago, when our ancestors were walking the African savanna and the genus Homo had not yet appeared. And it is approaching. Andromeda and the Milky Way are falling toward each other under their mutual gravitational attraction, and in about 4.5 billion years, they will collide. Galaxy collisions are not violent in the way that word usually implies. Stars are so widely spaced that two entire galaxies can pass through each other without a single pair of stars actually colliding. What happens instead is a slow gravitational dance. Stars thrown into new orbits, the two galaxies merging over hundreds of millions of years into a new, larger elliptical galaxy. By then, the Sun will be near the end of its life. Fact number 58. There are more galaxies in the observable universe than grains of sand on Earth's beaches. For decades, the estimate was that the observable universe contained about 200 billion galaxies. A 2016 study revised this estimate dramatically upward to at least 2 trillion galaxies, accounting for smaller, fainter galaxies that earlier surveys had missed. 2 trillion, the number of grains of sand on all of Earth's beaches, is estimated at around 7.5 1.5 quintillion, a 1 followed by 18 zeros. 2 trillion is 1,000 billion, a 1 followed by 12 zeros. The galaxies outnumber the beach grains by a comfortable margin. Each galaxy contains hundreds of billions of stars, each star potentially surrounded by worlds. Fact number 59. The light from distant galaxies shows us the past. When we observe a galaxy 2 billion light-years away, we see it as it was 2 billion years ago, before the Earth had complex life, before even simple multicellular organisms had developed. When we observe a galaxy 10 billion light-years away, we see it as it was 10 billion years ago, when the universe was less than 4 billion years old, when galaxies were young and irregular, when the first heavy elements were only beginning to enrich the gas clouds from which future stars would form. Our telescopes are time machines. The deeper we look into space, the further back in time we see. The most distant objects we have observed, quasars and early galaxies, show us the universe as it was when it was less than 1 billion years old. We can watch cosmic history simply by looking further. Fact number 60. Our galaxy is part of a local group of about 50 galaxies. The Milky Way is not alone. It belongs to a loose collection called the local group, about 50 galaxies in total, spanning roughly 10 million light-years. The two largest members are the Milky Way and Andromeda. The rest are mostly dwarf galaxies, small, irregular collections of millions to billions of stars, rather than the hundreds of billions in large spiral galaxies. Some of these dwarf galaxies are satellites of the Milky Way. The Large and Small Magellanic Clouds, visible from the southern hemisphere as detached pieces of the Milky Way, are two examples. They orbit our galaxy, being slowly pulled apart by tidal forces, their stars gradually being incorporated into the larger galaxy they circle. Fact number 61. Galaxy clusters are the largest gravitationally bound structures. The local group is itself part of a larger structure, the Virgo supercluster, which contains dozens of galaxy clusters. And the Virgo supercluster is part of an even larger structure, the Laniakea supercluster, which contains about 100,000 galaxies across 500 million light-years. The word Laniakea comes from the Hawaiian, meaning immeasurable heaven. Laniakea is not gravitationally bound. It will be torn apart by the expansion of the universe. But within it, all those galaxies are connected by the web of gravity and dark matter, their motions influenced by each other across distances that make the solar system seem like a room. The Milky Way is one dot in Laniakea. Laniakea is one structure among many. Fact number 62. Spiral galaxies have arms because of density waves. The spiral arms of a galaxy like the Milky Way are not rigid structures that stars orbit within. They are more like traffic jams, regions of higher density that move through the galaxy, with stars entering and exiting the arms as they orbit. Stars passing through a spiral arm are compressed slightly, which can trigger star formation. This is why spiral arms appear bright. They contain many young, hot, luminous stars recently formed by this compression. The arms glow with new starlight. As stars age and move away from the arm, the bright young ones have burned out, and only longer-lived, dimmer stars remain. The spiral pattern is sustained by the wave of density, not by any permanent grouping of stars. Fact number 63. The universe is expanding in all directions. Edwin Hubble's observation in 1929 that distant galaxies are moving away from us, and that the further away they are, the faster they are receding, established that the universe is expanding. This is not like an explosion with a center where things move away from a single point. It is the expansion of space itself, every region of space expanding relative to every other. From any galaxy, all other galaxies appear to be receding. There is no center, There is no edge. Every point is equally the center of an expanding universe. What is expanding is not the galaxies themselves, but the space between them. Gravitationally bound systems, like galaxies, and solar systems within galaxies, do not expand. Only the vast spaces between unbound structures grow. Fact number 64. Dark matter makes up most of the matter in the universe. When astronomers measure how fast the stars at the outer edges of galaxies orbit the galactic center, they find something wrong. Based on the visible mass of the galaxy, the stars and gas we can see, those outer stars should orbit slowly. They don't. They orbit fast, too fast, as if there were more mass in the galaxy than we can see. The conclusion, supported by multiple independent lines of evidence, is that galaxies are embedded in large halos of some kind of matter that does not interact with light, does not emit it, absorb it, or reflect it. It is detectable only through its gravitational effects. This dark matter appears to make up about 85% of all the matter in the universe. We don't know what it is. We have never directly detected a dark matter particle, but without it, the universe we observe makes no sense. Fact number 65. Dark energy is accelerating the expansion of the universe. In 1998, two independent teams measuring the expansion rate of the universe found something unexpected. Distant supernovae were dimmer than predicted, further away than they should have been if the expansion was slowing down. The expansion was not slowing, it was speeding up. Something is driving the expansion of space to accelerate. Astronomers call it dark energy. It appears to permeate all of space uniformly and to make up about 68% of the total energy content of the universe. What dark energy actually is, whether it is a constant property of space itself, or a dynamic field that changes over time, or something else entirely, is not known. It is one of the most significant open questions in all of physics. We have measured its effects. We do not understand its nature. Fact number 66. The cosmic microwave background is the oldest light we can observe. About 380,000 years after the Big Bang, the universe had cooled enough that electrons and protons could combine to form neutral hydrogen atoms for the first time. Before this moment, the universe was opaque. Light could not travel freely because it was constantly scattered by the dense plasma of free electrons. When the electrons combined with protons, the universe became transparent. The light that was free to travel at that moment has been traveling ever since, stretched and cooled by the expansion of the universe. Until today, it fills all of space as microwaves, detectable in every direction as a faint, nearly uniform glow at a temperature of about 2.7 degrees above absolute zero. This cosmic microwave background is a snapshot of the universe at 380,000 years old, the oldest image we have of the early cosmos. Fact number 67. The universe was once smaller than an atom. The current leading model of cosmology, supported by multiple independent observations, holds that the very early universe underwent a period of extraordinarily rapid expansion called inflation. In the first tiny fraction of a second after the Big Bang, the universe expanded from a size smaller than a subatomic particle to a size many times larger than the current observable universe, all in a time span far shorter than a trillionth of a second. The tiny quantum fluctuations present at the beginning of inflation were stretched to cosmic scales by this expansion. Those fluctuations became the seeds of structure, the slight density variations that, over billions of years, gravity grew into the cosmic web of galaxies and voids. Everything we can observe is the amplified echo of microscopic quantum noise from the universe's first moment. Fact number 68. Other universes may exist. The same physics that produced the observable universe may have produced, or be producing, others. Several theoretical frameworks predict the existence of a multiverse, a larger realm within which our universe is one of many. In eternal inflation, different regions of space stopped inflating at different times, producing separate universes with potentially different physical constants. In string theory, a vast landscape of possible universes exists, each with different properties. In the many worlds interpretation of quantum mechanics, every quantum event generates branching realities. These ideas are genuinely scientific. They arise from rigorous mathematics, but none of them are currently testable. We cannot observe other universes. Whether they exist may be a question physics can eventually answer, or a question that lies permanently outside the reach of observation. For now, it is simply an honest accounting of what the mathematics allows. Fact number 69. The observable universe is about 93 billion light-years across. This seems paradoxical. The universe is only 14 billion years old, so how can it be 93 billion light-years across? The answer is expansion. In the time since light left the most distant objects we can observe, those objects have continued to move away from us as space expanded. They are now much farther from us than the distance the light traveled. The light has been traveling for 13.5 billion years, but the sources of that light are now about 46 billion light-years away. The observable universe, the sphere of space from which light has had time to reach us, has a radius of about 46 billion light-years in every direction. Beyond that, there is more universe, but its light has not yet reached us. Fact number 70. The universe may be infinite. The observable universe is finite, bounded by the distance light has had time to travel in the age of the universe. But the universe itself may extend far beyond what we can observe, perhaps infinitely. If the universe is infinite, it contains an infinite number of stars, an infinite number of galaxies, an infinite number of planets. And in an infinite universe, every configuration of matter that is possible will in fact occur infinitely many times. We don't know whether the universe is infinite. It appears geometrically flat on the largest scales we can measure, which is consistent with either infinite or very large, but finite. The question may be permanently unanswerable, since any observation can only ever sample our finite, observable region. The universe may be boundless. That is a strange and quiet thing to consider in the dark. Fact number 71. The fate of the universe depends on dark energy. If dark energy remains constant, the expansion of the universe will continue to accelerate indefinitely. Galaxies beyond a certain distance are already receding faster than light, not because they're moving through space faster than light, but because the space between us and them is expanding faster than light can cross it. Over trillions of years, those galaxies will fade from view entirely. The universe will become increasingly empty and cold. Stars will exhaust their fuel. Black holes will slowly evaporate through Hawking radiation. In the far, far future, timescales that make the current age of the universe seem like a fraction of a second, even the black holes will be gone. What remains is a universe of almost pure, cold, empty space, gradually fading toward absolute zero. This is called the heat death of the universe. It is not imminent. It is not a cause for anxiety. It is simply the logical conclusion of physics as we understand it, and it lies so far in the future that every star that has ever existed or will ever exist will have burned out countless trillions of years before it arrives. Fact number 72. A star is being born somewhere in the galaxy right now. In the vast nebulae scattered through the Milky Way, gas and dust are collapsing under gravity at this moment. New stars are igniting. The cycle that has been ongoing since the galaxy was young continues, quietly, right now. The Orion Nebula, the Eagle Nebula, these are active stellar nurseries. New suns are forming in them, some of which may have planetary systems, some of which may host worlds where conditions could allow chemistry to grow complex. This process has been ongoing for 10 billion years. It will continue for billions more. The universe is not static. It is in constant, slow, creative motion, building new things from the scattered material of old ones. Fact number 73. Light pollution has hidden the universe from most humans alive today. For most of human history, anyone who looked up at night on a clear evening could see the Milky Way, the great band of the galaxy stretching overhead. Today, roughly a third of humanity cannot see the Milky Way due to artificial light pollution from cities and towns. The stars have not moved. The galaxy is still there, but the artificial glow of human civilization washes out everything but the brightest celestial objects. Ancient people, everywhere on Earth, in every culture, had the night sky as a constant presence. Its patterns drove navigation, agriculture, religion, calendar keeping. The stories told about it were among the first stories humans told at all. What has been lost to light pollution is not trivial. It is a direct connection to the scale of things, available to every person who had ever lived until very recently. Fact number 74. Some of the oldest things in the universe are still observable. The oldest stars, found in globular clusters, dense spherical collections of hundreds of thousands of stars, are nearly as old as the universe itself. Some are estimated to be 13 billion years old, formed in the first billion years after the Big Bang. These stars contain very little of the heavier elements that later generations of stars produce. They are made almost entirely of hydrogen and helium, the original elements of the universe, before any star had lived and died, and enriched the gas clouds with the ashes of fusion. When you observe a globular cluster, you are seeing stellar populations that formed when the universe was young, when galaxies were irregular and star formation was prodigious. They have survived for most of cosmic history, orbiting the centers of their galaxies, witnessing billions of years of cosmic change while changing themselves very little. Fact number 75. The universe was dark for millions of years. After the cosmic microwave background was released, after the universe became transparent, there was a period lasting hundreds of millions of years when the universe contained no stars. The hydrogen and helium gas that filled space after the Big Bang was slowly collapsing under gravity into the first structures. But the first stars had not yet ignited. There was no light source. The universe was dark and cold and silent for a long time, sometimes called the cosmic dark ages. Then the first stars lit up. They were likely enormous, hundreds of times the mass of the sun, burning bright and brief, living only a few million years before exploding and enriching the surrounding gas. Their light ended the dark ages. The universe has been lit since. Fact number 76. Some stars have been orbiting the galaxy since it formed. The galaxy has been rotating for roughly 13 billion years. The oldest stars in the Milky Way have been making that journey, circling the galactic center on orbits that take hundreds of millions of years, for almost all of that time. In 13 billion years, those stars have orbited the galactic center perhaps 50 or 60 times. They have watched the galaxy grow, watched younger generations of stars ignite and die, watched the disk of the Milky Way form from the scattered debris of early star formation. The Sun, at about 4.5 billion years old, is a relative newcomer. It has only made about 20 orbits. The oldest stars have seen what no living thing in the solar system can imagine, the galaxy as it was when the universe was young. Fact number 77. Water is surprisingly common in space. Water, hydrogen, and oxygen is the most abundant complex molecule in the universe. It exists in vast clouds of interstellar gas. It forms on the surfaces of dust grains in cold molecular clouds. It coats comets and asteroids. It lies beneath the surfaces of moons and dwarf planets. The solar system contains enormous quantities of water beyond Earth. There is strong evidence for liquid oceans beneath the ice crusts of Europa, Enceladus, Ganymede, and Titan. Mars has large quantities of water ice at its poles and underground. Comets are largely water ice. The element oxygen is the third most abundant in the universe after hydrogen and helium. Hydrogen is the most abundant. When the two meet, under the right conditions, water forms readily. The universe appears well stocked with the conditions for it. Fact number 78. Sunsets on other planets are different colors. On Earth, sunsets are red and orange because the atmosphere scatters blue light more efficiently than red. So the longer red wavelengths reach your eyes when the sun is low, and its light travels through more atmosphere. On Mars, where the atmosphere is thin and full of fine red dust, sunsets are blue. The dust scatters the light in a way that produces a blue tinge in the sky near the sun, surrounded by a pinkish red elsewhere. On Titan, Saturn's largest moon, the sky is a hazy orange, and the sun, visible as a brighter point in the diffuse glow, would set without the vivid colors of Earth. On Venus, if you could stand on the surface without being crushed and melted, the sky would be a deep, oppressive orange-yellow from the thick clouds of sulfuric acid. Every world that has an atmosphere has its own sky. The blue of Earth's sky is not the universe's default. Fact number 79. The universe is mostly emptiness. Not just the space between stars or between galaxies. Matter itself is mostly empty. The nucleus of an atom is tiny. If an atom were the size of a football stadium, the nucleus would be a grain of sand at the center. The electrons occupy a vast region of probabilistic space surrounding that nucleus, but they are not physical balls filling that space. They are quantum fields, fundamentally different from anything in everyday experience. The solid ground beneath you is mostly empty space. The atoms in it are almost entirely the distances between their nuclei and their electron clouds. What you experience as solidity is the electromagnetic force preventing those spaces from overlapping. The universe is a vast emptiness, in which tiny concentrations of matter and energy occasionally produce things like stars and planets, and people wondering what it all means. Fact number 80. The universe may have existed before the Big Bang. The standard model of cosmology describes the Big Bang as the beginning of space and time as we understand them, the initial singularity from which the observable universe emerged. But some theories suggest that what we call the Big Bang was not the beginning of everything, only the beginning of the universe we inhabit. In cyclical cosmologies, universes form and collapse repeatedly. In some inflationary models, the Big Bang was a local event in a larger, eternal inflationary background. The concept of before the Big Bang is deeply problematic because time itself may have emerged with the Big Bang. Asking what came before may be like asking what is north of the North Pole. But it is not a settled question. The nature of time and whether the universe had a true beginning remains genuinely open. Fact number 81. The elements in your body have a long history. The hydrogen atoms in you were made about 14 billion years ago, in the first few minutes after the Big Bang. The oxygen atoms were made inside stars that lived and died billions of years before the sun was born. The iron in your blood was forged in the core of a massive star and scattered into space when that star exploded as a supernova. The calcium in your bones came from similar stellar deaths. The phosphorus in your DNA, the nitrogen in your proteins, all of it assembled inside stars whose names we will never know, in a galaxy that has been recycling stellar material for 10 billion years. You are not merely influenced by the universe. You are not merely in the universe. You are the universe, momentarily organized into a form that can contemplate itself. Fact number 82. The cosmic year is about 230 million years. The length of time it takes the Sun to complete one orbit around the center of the Milky Way, the cosmic year or galactic year, is about 230 million Earth years. In that time, one trip around the galaxy, the dinosaurs rose and fell. The continents moved substantially. Entire mountain ranges were raised and eroded. Species appeared and went extinct by the millions. The universe is old enough to have contained about 60 galactic years. The Sun has completed about 20. These numbers are almost entirely too large to hold in the mind. And yet here we are, small and temporary, making sense of them with brains that evolved to navigate a savanna. Fact number 83. The universe contains about 2 trillion galaxies, each with hundreds of billions of stars. 2 trillion galaxies, 300 billion stars per galaxy on average. The total number of stars in the observable universe is estimated at roughly 2 times 10 to the 23rd, about 2 followed by 23 zeros. This is comparable to the number of grains of sand on all of Earth's beaches and deserts combined. And if even a small fraction of those stars have planets, and a small fraction of those planets have conditions favorable for chemistry to grow complex, the numbers become difficult to think about. The observable universe is not the whole universe. It is simply the part from which light has had time to reach us. What lies beyond is unknown, and may be as large again as what we can see, or larger by any factor, or infinite. Fact number 84. There is a giant void in the universe called the Boots Void. About 700 million light-years from Earth lies a region of space called the Boots Void, a roughly spherical expanse about 330 million light-years across that is nearly empty of galaxies. The voids in the cosmic web are expected features of the large-scale structure, but the Boots Void is unusually large, containing far fewer galaxies than would be expected even for a typical void. Its origin and the reason for its unusual scale are not fully understood. If our galaxy were located inside the Boots Void, the night sky from Earth would have appeared far darker. The nearest galaxies would have been much further away. The Milky Way's nearest neighbors would have been barely visible. It would have been a lonely region of the cosmic web. We are not in the void. We are in a relatively rich region of the universe, surrounded by neighbors. Fact number 85. The Sun is an ordinary star in an ordinary position. The Sun is not at the center of the galaxy. It is not in one of the major spiral arms. It is not near any particularly spectacular nebula or cluster. It is in a quiet region, about halfway out from the galactic center, in a minor arm. In terms of stellar mass and luminosity, the Sun is slightly above average, but not exceptional. It is in the most common mass range for stable, long-lived stars. This ordinariness is sometimes called the Copernican principle, the observation that our position in the universe is not special or privileged. We are not at the center of the solar system. We are not at the center of the galaxy. We are not in a special galaxy or a special supercluster. We are somewhere in the middle of everything, which is another way of saying that we are as well placed as anywhere else. Fact number 86. The first stars were made of only 2 elements. When the first stars formed, less than 1 billion years after the Big Bang, the universe contained almost no elements other than hydrogen and helium, with trace amounts of lithium. These first stars, sometimes called population III stars, had no carbon, no oxygen, no iron. They were made of the primordial gases, and because there were no heavy elements to cool the collapsing gas clouds efficiently, they may have grown to masses hundreds of times larger than the Sun. None of them survive. They burned through their fuel rapidly and died in enormous explosions, scattering the first heavy elements into the universe. The second generation of stars, population II, formed from gas enriched by those explosions, and the stars of our generation, population I, formed from gas further enriched by subsequent stellar generations. We are made of the ashes of multiple stellar generations. Fact number 87. The universe has background radiation in every direction. Wherever you point a sensitive enough radio telescope, you detect the same faint glow, the cosmic microwave background, the afterglow of the early universe. It is nearly perfectly uniform, the same temperature in every direction to about 1 part in 100,000, but not perfectly uniform. The tiny variations, the slight temperature differences from one patch of sky to another, are the primordial fluctuations from which all cosmic structure grew. These fluctuations were first mapped in detail by the COBE satellite in the early 1990s, and more precisely by the WMAP and Planck missions since. The maps show a universe that is consistent in every detail with the theoretical predictions of inflation, dark matter, and dark energy, a remarkable confirmation that the basic framework of modern cosmology is correct. The universe is soaked in the faint warmth of its own beginning. Fact number 88. Some galaxies have stopped forming stars. In the universe today, some large elliptical galaxies have exhausted or expelled their supply of cold gas, the raw material for star formation. Without it, no new stars can form. These galaxies are called red and dead. Red because only long-lived lower-mass stars remain, and dead because the stellar population is aging without replenishment. The Milky Way is still forming new stars at a rate of a few solar masses per year, but its star formation rate has declined from much higher rates in the early universe. Over billions of years, as galaxies use up their gas, the rate of star formation across the entire universe will decline. The great age of stars, which has been ongoing for nearly 10 billion years, will eventually come to an end. The universe will age into an era of stellar darkness, populated only by the slowly dimming remnants of stars formed long before. Fact number 89. The speed of light is finite, which means we're seeing the universe in layers of the past. When you look at the moon, you see it as it was 1 second ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest large galaxy, Andromeda, you see it as it was 2.5 million years ago. When the most powerful telescopes peer at the most distant galaxies, they see the universe as it was nearly 14 billion years ago. They are not imagining the past, they are literally receiving light that has been traveling since the universe was young. This means that a complete picture of the universe at any single moment is impossible. Every observation is a composite of many different moments, layered by distance. The universe, as it exists right now, simultaneously, everywhere, is invisible to us. We only ever see the past. Fact number 90. A black hole's shadow has been photographed. In 2019, the Event Horizon Telescope, a network of radio observatories spanning the entire Earth, coordinated to function as a single telescope the size of the planet, produced the first image of a black hole's shadow. The target was the supermassive black hole at the center of the galaxy M87, about 55 million light-years away. The image showed a bright ring of glowing gas surrounding a dark central region, the shadow cast by the event horizon, where the intense gravity bends light around it. The image matched the theoretical predictions of general relativity to extraordinary precision. In 2022, a similar image was produced of Sagittarius A star, the black hole at the center of our own galaxy. The same ring, the same dark heart, close enough in cosmic terms that it is essentially our neighbor. Fact number 91. The universe is mostly made of things we don't understand. Ordinary matter, atoms, everything that stars and planets and people are made of, makes up only about 5% of the total energy content of the universe. Dark matter makes up about 27%. Dark energy makes up about 68%. So 95% of the universe is composed of things whose fundamental nature is unknown. We know dark matter and dark energy exist because of their effects. We do not know what they are. We have no verified laboratory detection of dark matter particles. We have no theoretical consensus on the nature of dark energy. The 5% we understand, the matter we can see and touch and build with, is a minority constituent of the cosmos, floating in a sea of the unknown. Fact number 92. Gamma-ray bursts are the most energetic explosions in the universe. Lasting anywhere from milliseconds to minutes, gamma-ray bursts are extraordinarily powerful events. For a brief moment, a single burst can outshine an entire galaxy. They are thought to arise from two sources: the collapse of a massive star directly to a black hole, creating a long-duration burst, and the merger of two compact objects, neutron stars, or a neutron star and a black hole, creating a short-duration burst. The energy released in some gamma-ray bursts exceeds what the Sun will emit over its entire 10 billion-year lifetime, concentrated into seconds. Fortunately, there are no gamma-ray burst progenitors close enough to pose any threat to Earth. We observe them from billions of light-years away, where they are scientifically fascinating and entirely harmless. Fact number 93. We have sent objects beyond the solar system. Voyager 1, launched in September 1977, is currently the most distant human-made object, more than 14 billion miles from Earth, well beyond the heliosphere, in true interstellar space. It is still transmitting. The signals, traveling at the speed of light, take about 22 hours to reach Earth. At its current speed, it would take about 73,000 years to reach the nearest star system. It will not go there. It is not aimed at any star. It is simply moving through interstellar space, carrying a golden record with sounds and images of Earth, an artifact of one civilization placed in the slow stream between the stars. In millions of years, when the solar system has changed entirely, when humanity has become something unrecognizable or is gone, Voyager 1 will still be traveling, a small, silent capsule in the vast dark. Fact number 94. The universe's expansion was discovered by measuring galaxies. In the 1920s, Edwin Hubble observed that the light from distant galaxies was shifted toward the red end of the spectrum, redshifted, as if the galaxies were moving away from us. The more distant the galaxy, the greater the redshift, indicating they were receding faster. This was the observational basis for the expanding universe, combined with Einstein's equations of general relativity, which had already predicted that a static universe was unstable and would either expand or contract. The observations established that space itself is growing. Running the expansion backward in time, if the universe is growing, then it was once smaller, then smaller still, leads to the conclusion that all the observable universe was once concentrated in an extremely small, extremely hot, extremely dense state, what is now called the Big Bang. Fact number 95. Stars in globular clusters are very close together. Globular clusters, spherical collections of hundreds of thousands to millions of stars, densely packed and very old, give a sense of how different stellar neighborhoods can be. In the core of a dense globular cluster, the distance between neighboring stars may be only a fraction of a light-year, close enough that at night, on a planet orbiting one of those stars, the sky would blaze with thousands of stars bright enough to cast shadows. The night sky in a globular cluster core would be unlike anything visible from Earth, a sky full of light in every direction, almost as bright as our full moon in some regions. From outside, globular clusters appear as fuzzy points of light, barely distinguishable from individual stars. From inside, they would be a blazing, crowded neighborhood. Fact number 96. The sun's light takes about 100,000 years to escape the sun. Inside the sun's core, photons, particles of light, are produced by nuclear fusion, but they don't travel directly outward. The interior of the sun is so dense that a photon travels only a tiny distance before being absorbed and re-emitted in a random direction. This random walk, absorbing and re-emitting over and over, takes an average of about 100,000 years for a photon to work its way from the core to the surface. Once it reaches the surface, it escapes and travels the rest of the 93 million miles to Earth in about 8 minutes. The light warming your face on a sunny afternoon has been traveling since the core of the sun for 100,000 years, and then made the final journey in 8 minutes. Fact number 97. The universe allows for carbon-based chemistry to be extraordinarily complex. Carbon is unique among elements in its ability to form long, stable chains and rings with other atoms. It can bond with up to 4 other atoms simultaneously in a vast variety of configurations. This gives carbon chemistry, organic chemistry, an almost unlimited diversity of possible molecules. The molecules of life, DNA, proteins, carbohydrates, fats, are all carbon-based. The complexity of living systems arises directly from carbon's bonding versatility. Carbon was produced in stellar interiors through a nuclear reaction that requires a precise alignment of energy levels, a resonance that allows 3 helium nuclei to combine into carbon. If this resonance was slightly different, carbon would not form in stars. The universe would contain almost no carbon. Chemistry would be limited. Life, as we know it, would not exist. This fine-tuning, whether it is remarkable coincidence or evidence of something deeper, remains one of the most discussed topics at the intersection of physics and philosophy. Fact number 98. The observable universe has a boundary, but the universe likely doesn't. The observable universe, the sphere of space from which light has had time to reach us, is finite. It has a radius of about 46 billion light-years. But the universe itself, according to our best models, extends far beyond this boundary. How far beyond is unknown. Some estimates, based on the flatness of the universe's geometry and the uniformity of the cosmic microwave background, suggest the total universe could be at least 100 times larger than the observable universe. Some models predict it is much, much larger. Some predict it is infinite. We cannot know because the rest of the universe is causally disconnected from us. Even light from beyond the observable boundary has not had time to reach us, and the expansion of the universe means that in some directions it never will. We live inside a sphere of knowledge embedded in an ocean of the unknown. Fact number 99. Silence is not the natural state of the universe. The universe is permeated by radiation, light of all wavelengths, from radio waves to gamma rays, filling every direction of space. The cosmic microwave background glows everywhere at once. Stars emit X-rays, ultraviolet light, visible light, infrared. Interstellar gas emits radio waves. Black hole jets emit high-energy radiation across the spectrum. The silence you experience in a quiet room is the silence of your senses. Ears detecting nothing above the threshold of hearing. Eyes registering only the visible spectrum. But an array of instruments sensitive to other frequencies would reveal a universe buzzing and glowing in every direction. Even in the remotest void, between the galaxy clusters, radiation passes through. There is no place in the universe that is truly quiet, only places where the instruments available to you cannot detect what is already there. Fact number 100. You are made of the oldest things in the universe, arranged in one of its newest configurations. The hydrogen in the water in your cells is about 14 billion years old. Some of the heavier elements were forged in stars that lived and died 9 or 10 billion years ago. The Earth itself formed 4.5 billion years ago from the scattered material of ancient stellar deaths. Your body, its specific arrangement of atoms into this particular person, in this particular moment, is extraordinarily new. The configuration is recent. You as a coherent self, reading or listening in the dark, thinking these thoughts, this is the newest thing in a universe full of ancient things. You are a rearrangement of the universe's oldest ingredients. The hydrogen that crossed 14 billion years of cosmic history arrived in you. The carbon that was fused in a star's core, scattered in a supernova, gathered into a solar nebula, incorporated into a rocky planet, organized into molecules by the chemistry of life, all of it is here. The universe, in its long history, has been many things: gas, fire, dark, stars, stone, ocean, life. And for a while, in a small corner of a modest galaxy, it has been you. The light of 100 facts. All of it has been traveling tonight, from neutron stars and quasars, and the edge of what we can observe, across billions of years of dark, toward this room, toward this moment. You are not separate from any of it. The oxygen you're breathing was made in a star. The iron in the blood moving through you right now was scattered by a supernova explosion that happened before the Earth existed. The calcium in your bones, the carbon in every cell, the water your body is mostly made of, all of it has been here since the universe was young, in different forms, part of different structures, before it found its way to you. Carl Sagan said that we are a way for the universe to know itself. This is not poetry. It is the most accurate description of what you are that physics allows. 13.5 billion years of history arranged into a form that can look up at the sky and ask where it all came from and spend a night moving through the answers. The universe is enormous. You are small within it, but small is not the same as insignificant. A planet is small relative to a galaxy, but a planet is the only known place where the matter of the universe has organized itself into something that asks questions about the galaxy. You are one of the known places, perhaps one of many, perhaps the only one. The universe has not told us which. Let the questions rest for tonight. Let the scale of things hold you, not as something overwhelming, but as something ancient and vast and indifferent in the most peaceful sense. The universe has been here for 14 billion years. Your worries are not nothing, but they are held inside something incomprehensibly larger. And that larger thing does not require anything from you tonight. You don't need to understand it. You don't need to hold it. You don't need to figure anything out. The stars are doing what they always do. The galaxy turns. The cosmic background hums its 2.7-degree hum in every direction. And somewhere, on a small planet circling an ordinary star, a person is drifting towards sleep. The universe notices in its way. It holds everything, including this. Sleep well.